Thank you for tuning in to listen to some of the work that I've been doing in my quantum mechanics class that's been supported by the HHMI Course Innovation Grants. So, for those of you who don't know, quantum mechanics is one of our lecture courses that is part of the core sequence of physics classes for the juniors and seniors. Not all physics majors take quantum mechanics, but most of them do. I would say only a couple opt not to. And so quantum mechanics turns out to be one of the courses that is sort of central towards developing what it means to finish Kenyon with a physics major, and it also has a lot of the really cool conceptual pieces of physics that a lot of students look forward to learning about. So the trouble is that pedagogy in physics, or the research that's gone into physics, has mostly centered on the large introductory lecture courses. And there's a lot of evidence, as we all probably know, that says that the key to effective pedagogy is to get students doing things, right? So in the first year, we've been successful as a department, much of which has been supported by HHMI, but we've been working towards moving active learning into the curriculum. Getting active learning into the advanced curriculum is somewhat harder, and the research on that is somewhat newer. But what we wanted to do is take advantage of the opportunities, and I should say there are very few silver linings of the pandemic situation. But one of them is the opportunity to say, let's deconstruct those things that we used to do and find out whether or not there is a better way or there is another way of teaching these advanced classes. So traditionally what would happen is that upper level theoretical, sometimes we call them more lecture course, would comprise of 3 lectures a week. Okay, maybe you would assign readings from the textbook before the lectures. I think we all know how many of our students actually complete those readings, since there's no assessment of whether they do. But there would be readings, 3 lectures a week that go through the narrative of the textbook, say, or go through the narrative of the lecture notes. Every student would then complete a weekly individual problem set, which would be graded by hand and then turned back probably within a week or 2, depending on how busy we are. There might be 2 midterm exams that we tended to teach these. We tended to proctor these at night, right? So that they would be maybe 2-hour exams and then a comprehensive high-stakes final. So this past fall, it seemed that many of the things that we were doing in these traditional courses just wasn't going to work here. Plus, we had 26 people enrolled in quantum mechanics, which was one of the biggest sections of quantum mechanics that we've ever had. So there really was a chance to take this and get some data about whether any of these teaching innovations could actually make a difference in the outcomes of the class. So this past semester, the first thing I did was I really played with the entire the entire top to bottom structure of how the class went. So the first was moving all of the ingestion, right? That is the passive learning, moving that off outside of the class hours. So there were both pre-class readings, but also there were videos, and then there were Moodle quizzes that went along with those readings and videos, just to make sure that they were completed. Then every day during our 50-minute class period, we would have some sort of active learning technique, and I'll get into that in a minute. But also throughout the week, students would be assigned to teams. Now, I call them group problem sets here, but in class I was very careful to always call it, team exercises, because I think that word was particularly important. But then at the end of the week, the students, rather than doing an individual problem set, would turn in a team problem set. And early the following week, those problem sets would not be graded blindly, right? The students would have a meeting with me where we go through the problem set and I can ask them questions. And so there was a feedback loop that was closed. There were no midterm exams, so that way we had the rhythm of this weekly structure throughout the entire semester. And then rather than a high-stakes written final exam, there was an oral final exam where we could focus on large questions, and I could also ask. I could investigate different nuances of student understanding. But the other thing that I added to the class, and these are these really were new innovations rather than just reworking some of the old structures. Rather than having optional office hours and problem sets as the only means of assessment, I required each team to come to a weekly tutorial. So this was, again, a 45-minute appointment outside of class, where the teams would sign up for a time to talk with me about the problem set. And then and then a number of times during the semester, they would be required to fill out a fairly comprehensive self-assessment of their work. So that way they could have a chance to both think about the narrative and the feedback that they have gotten, but also to sort of do some metacognitive work with the stuff that they've been learning. Okay. So the week looks something like this, okay? On Mondays, so during our 3 in-class times, on Mondays, the first thing we would have is an emotional health community check-in, right? So we would go around and everybody would hear everybody else's voice, right? This was a purposeful way of checking in and creating community in the class. After that, people would find out who's in their group. These were always assigned randomly. They would get then the weekly problems, and they would sit down with their group and sign up for, and I used Google scheduling to do this, they would sign up for their tutorial, which would happen later in the week, and then their work assessment, which would happen early the next week. On Wednesdays in class, we had what was called Work Together Wednesday, where we would actually spend some time working on problems that were either identical or similar to the problems that were on the problem set, but we would all focus on a certain set of problems, and teams would work together on them, so that way, again, they could have some structured team time while I could go around to individual breakout rooms. And then on Friday, we would have Friday Apply Day, which actually took the topics for that week and applied it to another problem, maybe with a computational twist or a visualization, but something that actually wasn't ever directly assessed, right? But the students would be able to see what are the topics that we're learning about and how might they apply to some different problem. And a couple of times during this semester, other faculty members from the department would give me examples of how this interfaces with their work, and sometimes they even came to class to talk about the applied activity for that day. So my goals were multiple engagements every week, right? So not only just in class, but also through the tutorial and the work assessments to be able to have a conversation and hear the voice of every student, what turned out to be about 5 times a week. Also, purposeful assessment, right? So rather than turning back things, and I actually have anecdotes about how little students will tend to read Moodle feedback, but I want them to hear my words, right? And I want them to hear my feedback. And so while I'm writing on their problem set, to have a conversation with them gives them a chance to really understand feedback and ask follow-up questions. And then, of course, the whole structure here is to focus on connections and collaboration. This is an advanced physics class where students are honing their skills for how to work together and how to be a team, right? And these are both pre-science career goals, but also just pre-professional goals in general. So, what was I trying to measure then, or what were we trying to measure with this course innovation grant? Well, the first thing is, and this is specifically to do with making sure that the structure not only appeals to all students, but specifically helps to address the issues surrounding students who are historically marginalized. Do all students feel like they belong in class or belong in the field or belong in science? Okay, and so belonging was central to what I wanted to measure, right? Are these techniques something that's going to make it so that students develop a physics identity? The second thing is confidence, right? Do students feel like they can succeed in this class or another class, or just doing hard things in their lives? And the third question was, can we achieve the same learning goals, but without the structures that we thought we really needed? So we did pre and post surveys. What I'm going to present here are actually the responses from the post survey, which asked questions about how you felt at the time of the pre-survey, at the time of the beginning of the class. I communicated with IR about this, and they thought that maybe this was a good measure to take because students at the end of the course can look back, and that will indicate their growth, right? So that they have a moment to think about have they really changed in this, and so. Where you see the left-hand panels on the next couple of slides, those are at the beginning of the semester, but in the view of the end of the semester. And so the first question that I'm presenting here is just about belonging, right? And we can see that although belonging perhaps wasn't a problem at the beginning of the semester, it dramatically improved, right? Many students at the end of the year felt like they felt like they belonged more at the end of the semester than at the beginning. And what also was nice is that we also saw a much increased engagement with me, right, with the faculty member leading the class. Students at the end of the course really felt like they were more comfortable asking for help from the instructor than they felt like they did at the beginning of the class. And I think that this is almost every single student in the class, and so you really see that despite the fact that we were totally remote, the students still felt like they had engagement with me, and that these structures were supporting how confident they felt in coming to see me. So the second thing, of course, is explicitly about confidence. And again, we don't have we haven't yet done the deeper analysis of looking at different demographics. But what you see is that the sort of simple questions like, do you feel like you could be successful in a physics-related career? We had a big increase in those that strongly agreed with that. At the beginning of the semester, I believed I could keep working on difficult schoolwork, even if it frustrated me, right? So working through or persevering through frustration towards conclusions, that went way up in the strongly agree category. Also, I believe I could achieve understanding difficult concepts. Hugely increased, or people's perception of how they changed hugely increased. And then the last part of this assessment group is, could I overcome setbacks, right? And while at the beginning, while students felt like at the beginning of the semester they could, many more moved to that strongly agree point by the end of the semester. But then the last thing, that we explicitly asked about was this, this relationship, collaboration, and community, which was something that we were really in threat of losing, right, during this semester. And so asking classmates for help, again, huge increase in those that strongly agree. At the beginning of the semester, I felt comfortable coming to my professor to help with understanding lab material assignments, again, hugely increased over the course of the semester. I also, in the course evaluations, asked for some narrative thoughts on the structure of the class. And of the 26 students, I would say there were 2 or 3 that had some suggestions on this, but many felt like the work assessments in particular, sitting down after you turn in a problem set and hearing some feedback and having another chance at answering the questions was something that almost every student highly valued. But also a number of students found that the self-assessments hit their mark, so that they could start to think about how they were doing, and they were having that metacognitive experience that helps them to realize how far they've really come over the course of the semester. The last things that I just want to say are, although the work assessments and tutorials were widely popular, and I'm sold as the way to give feedback and for students to hear meaningful feedback, man, they're time consuming. And so thinking about how to manage faculty time in taking advantage of a procedure like this is something that really has to be thought through. I will also mention that in my oral assessment of the students at the end of the semester, I found no gaps in knowledge, and comparing their grade structure, they did just as well or better than students did when I taught in a traditional format. And also the distribution was narrower, and I think that there was there really is something to how engagement in this multi-stage process really helps students to stay on top of the material. And self-assessment is still an uncomfortable reality, and I think that in employing self-assessment in the future, I think really being more explicit about the goals of self-assessment is something that might make that easier for some students to do. So anyway, as I finish, I just want to say thank you to the HHMI team, institutional research, all the students that bore with me this whole semester. I really think we learned a lot about learning quantum mechanics.